Hello 30-1s, this is lesson 5.2, transformations of sinusoidal functions. So a vertical displacement is a vertical translation of a sinusoidal or periodic function. So this can be found by solving for the letter D, which is your max plus min divided by 2. Then your phase shift is your C value in the equation. So our C value tells you the horizontal translation of this sinusoidal function. So for example number 1, they want us to sketch the graph of y equals cos in brackets x plus 45 degrees minus 2. So first of all, if you want to graph this, you need to be in degree mode. Okay, so what you're going to do is you're going to put that into your calculator. So first change your mode to degrees, of course, and then go to your graphing calculator and graph cos in brackets x plus 45 and then outside the bracket minus 2. So you also want to change your window. So I'll show you what window you want to have. So our window will go from, if we're talking about degrees, we would go from 0 to 360. So I'll go slightly higher than that so it doesn't cut it off. So I'll go up to 400. And then for your scale, I would go up by, in this case, maybe every 45 degrees. So I'm kind of using this, the horizontal translation as a hint of what my scale would be. So for X, I'm going from 0 to 400 degrees, going up by 45. And then for Y, as you can see, the graph is moving because of a vertical translation. So I'm going to change my equation to go from, for y, -4 to +4. Okay, so what you want to do is you want to find the y-intercept. So we're going to start graphing this. This is our y and this is our x. So I'm going to make sure I sketch the values as I'm going to go -1, -2, -3, and -4. And for x, every 2, I'm going to put 45 degrees just to space it out a little bit. So I'm going to keep adding 45 degrees. Okay, so once you have that, you want to start by finding the y-intercept. So I would go trace 0, enter, and I know that my y-intercept is going to go through -1.29. So put a point there, and then from there you want to figure out what your minimum value is. So I'm going to figure out where my minimum occurs by going second trace, number 3. And I'm going to find out where that occurs by going to the left side of that minimum and then the right side of that minimum. So the minimum value occurs at 135 degrees at -3. So things that can help you in this equation is that the value in front of your cos will be your amplitude. So that's your height above and below your median value. So your median value, which is also called your midline, would be at -2. So this is the line that cuts it directly in half. So we're going to have a dotted line at -2, which means that our graph should be equally above and below this dotted line here. So that's my midline. Or we know it as a vertical displacement. And then we also know that the graph has moved 45 degrees, in this case, to the left when it comes to our phase shift. So we'll talk about that later. But what I'm just doing is I'm finding out what my minimum and maximum values are and then plotting around it. Okay, so I want to find out now the max. So I'm going to go second trace, and you're going to go to the maximum on the right side, and you're going to find out what the maximum is, so that way we can give a better sketch. So find your maximum height. And at what point it occurs, I know that it occurs at 315 degrees, and that's at -1. Okay, so what you want to start doing is we want to start now connecting these values together to give ourselves a picture of this image. And then we can even find out maybe at 360 what the value is by going trace 360, and we know that it's going to come back to its starting point. We know it's at 360, it's going to be at that -1.29 again. Right there. Okay, so we can continue on if we want to, but that would be enough. So I could put arrows here if I needed to. It says, what is the domain and range of this function? So the domain for this would be XCR, because the graph does continue for the left or right. There's no restrictions on this. It doesn't say anything else, so we can say that it continues on forever. The range of this graph would be that the lowest value that we have along the y is -3, and the highest value goes up to -1 YER. And then we want to describe the transformations that are occurring. So use the language of transformations to compare your graph to the graph of y equals cos of x. Well, we know that there's no vertical stretch or horizontal stretch, but there is a vertical translation of 2 units down. Okay, so that's why normally we would have the value, that midline, being at 0, but now it's gone 2 units down to -2. And then we also have a horizontal translation. So that's our phase shift. And so that's going to be 45 degrees to the left. Now, other pieces of information that are usually helpful would be the period. So we're going to just write that the period is equal to 360 degrees, because there is no horizontal stretch, so there's no change in the period. And our amplitude is the value in front of our cos, which is equal to 1. So our height above and below that midline is, if you look at the maximum versus the minimum, it should be above and below that midline by a value of 1. Okay, so that's all we needed to do for this first graph. Example number 2, now they want us to sketch this guy, but you need to change your mode, so now we're going to be in radian mode. Okay, so make sure you change your mode to be in radians, and then graph this exactly how you see it. So instead of theta, we're going to use x for our calculators. Now you're also going to have to change the window. So for our window, I'm going to go from 0 to 2 pi, so that would go up to 360 degrees, going up by in this case, we can go up by an increment of possibly pi over 2, because I'm just using kind of the phase shift to help me. So pi divided by 2 will be my increment. So I'll go from 0 to 2 pi up by pi over 2. And then for y, I know that the graph has moved 2 units up from its irregular position. So I'm going to go from, I'm going to keep it at -4 to +4, going up by 1. Okay, so now we want to sketch what this looks like. Okay, so we want to write our increments. So I'm going to have to go pi over 2. So that's the first one. Then it'll be, our next value would be 2 pi over 2, which is pi. And then it would be 3 pi over 2. Then it would be 4 pi over 2, which is 2 pi. And then this could continue on if I wanted to. So I can continue, but my window only shows one wave. So I'll draw this, and if I want to, I could draw another wave to continue this. So when we look at our value, if you go trace 0, enter, you should find that there's a y-intercept at the origin, 0, 0. So there should be a starting value at 0, 0. And then the next value that we need is our maximum. So what we could do is we can look at pi over 2 and go trace pi divided by 2 and see what values that gives us. Well, at pi over 2, it says that the value is at 2. Okay, so at pi over 2, we're going to plot the point at 2. Then we can do trace pi, and we can get that the value is 4. And then we can go trace 3 pi divided by 2. So we're just putting in the x values and then plotting what we get out of what we get for the y coordinate. 2 pi. We know that at 2 pi it's going to return to our 0 value. So that is one wave on this graph. And we can continue this. Okay, they do want us to continue for 2 cycles. So I'm going to change my window then to go to 4 pi, because right now I only had 1 cycle, so I want to continue this to show 2 pi. So this would have been 4 pi over 2, and then it would be 5 pi over 2, just to continue the pattern. 6 pi over 2 would be, 6 pi over 2 is the same as 3 pi. Then it would be 7 pi over 2, and then 8 pi over 2 is 4 pi. So that would be continuing 2 cycles. So what I'll do is I'll retrace the same values here. So I know that 5 pi over 2, it's going to be again at 2. Then at 3 pi, it's going to be at 4, just looking at the previous wave. Then at 7 pi over 2, it's going to be at 2 again. And then at 4 pi, it's going to go back to that x-axis. So there's 2 cycles there. So what they want us to do is they want us to compare this graph to y equals sine of theta. So I'm going to draw sine of theta here. So I'm going to do that in red. So we know that sine of theta always starts from the origin as well. And then what you should find is that it's going to have, if you go trace pi over 2, that should be the maximum at 1. And then at pi, it should be at 0. Then here, it should be at a minimum, and then back to 0 for 2 pi. So it's a little stretched out there. I messed up a little bit with the graph, but it'll still look the same. And then it goes back up to 1. And then back to the origin, down to -1, and back to the origin. So that is what the sine theta graph looks like in comparison to the 2 sine theta minus pi over 2 plus 2 over 2 cycles. So they do want us to compare. So what we can do is compare it by saying, well, we know that there has been, so this is using transformations. So the transformations that have occurred is that there has been a vertical stretch about the x-axis by a factor of 2. Okay, so that's one thing that we need. We also have a horizontal translation of pi over 2 to the right. And then we have a vertical translation of 2 units up. We can always compare the period as well, so we know that the period is going to be the same. So they're actually going to have the same period. And then your amplitude will be 2 on one, but then 1 on the sine. Okay, so they do have the same period, which is 2 pi, but they have different amplitudes. Example number 3, they want us to sketch what 4 cos 4 x plus pi minus 1 looks like over 2 cycles again. So what you want to do is you want to draw this, and then when you're doing this, you do want to put a double bracket here when you put this into your calculator. Now we can keep the same window as before. We do want 2 cycles, so since this is going to have more cycles within the same values, we only really have to go to, we can change our values to go up to possibly pi, so I'm going to try that. Okay, so I'll show you what my window that I used was. For x, I'm going to go from 0 to pi, going up by pi over 6. So pi over 6 is equivalent to 30 degrees, so I'm using that as my reference. And then my y value, I'm going to use the same window for y as before. Okay, so once you graph it, you want to sketch what this looks like. So this will be pi over 6, then 2 pi over 6, which is pi over 3, then 3 pi over, so that was pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi over 6, and then 8 pi over 6. Nine pi over 6, 10 pi over 6, 11 pi over 6. And then 12 pi over 6 would be 2 pi. Okay, so we just wanted to break it up and show all the little increments. So that's how you're showing how pi over 6 divides this graph. And then again, we have the same window for y. Okay, so if you look at the graph, you can go trace 0, enter, and find that the maximum occurs at 1. And then it seems to go down from there. So if you go trace pi over 6, you should find that that value is equal to, actually I want to do pi over 6. So, yeah, so pi divided by 6 is equal to -2. And then pi divided by 3 will come back to -2 again, because it does dip down lower than that. So I'm gonna find the minimum value by going second trace, number 3, and I'm gonna go to the left side of that minimum just to find out where that occurs, and then the right side of that minimum. Okay, so halfway in between here, you should find that the minimum actually goes to -3. Okay, so it starts to look like that. And then you can continue sketching the rest of the pieces. So I'm plotting out each of these to see where it actually takes me. So all of these values you'll notice that it does repeat itself. So 2 pi divided by 3 gives me -2 again. This one will give me positive -2 again, so it's just the same repetition. 7 pi divided by 6 will be that maximum again. Now technically I can stop here, so I just wanted to show you where I can stop. So 2 cycles will end you right here. So you don't have to continue the graph, you can just draw it up to that point right there. There you go. Okay, so that would be 2 cycles, and it says what are the vertical displacements? So we're going to start by writing that. So vertical displacement will be 1 unit down. So that's always that's always your d value when it comes to your sinusoidal function. Next one is the amplitude. The amplitude is your a value, so that comes in front of your cos or your sine. So in this case, the amplitude is 2. Then they want to know the period. The period, since we're in radians, we're going to have to go 2 pi divided by your b value, which is 4 in this case, and that's going to simplify to pi over 2. So what's happening is that this graph repeats itself every pi over 2. Our phase shift is our c value, and that's equal to pi degrees, or in this case radians, pi radians going to the left. Then they're asking for the domain and range. The domain is still going to be x such that x is an element of real numbers, because it does continue left or right forever, and our range is going to go from -3 to +1. Okay, so that's all the information that they were looking for. So vertical displacement, amplitude, period, phase shift, domain, and range for this function. Okay, so that's example number 3. Example number 4, it says the graph shows the function y equals f of x. Write the equation of the form in the form y equals sine. So what for sine and cos, what we'll notice is that the a, the b, and the d are identical for both graphs. The only thing that will change is the c value between them. So then you can always graph them to sketch the idea. So first we're going to start by finding the a value, which is your amplitude. So that can always be found by taking your max minus your minimum and dividing it by 2. So our maximum value is 1 minus our minimum value is -2, and we're dividing that by 2. So 1 plus 2 divided by 2 is 3 over 2. Oops. Sorry, guys. I'm just going to fix this. This should actually be -3. I was just looking at it. The minimum should be -3. So our minimum is -3 if you guys look at it right there. So that'll be 1 plus 3, which is 4 divided by 2. So that makes it a nicer number, which is good. So that will be 2. So our amplitude is 2. Our b value is our period. So our period can always be found. Since we're in radian mode, we're going to have to do 2 pi. So to find that, 2 pi divided by our period is how we find our b value. So in this case, we have 2 pi. Our period, we're going to have to see where it starts and where does it come back to that same location after a minimum and a maximum. So as you can see, it starts right here. It goes down to a minimum, goes up to a maximum, and then reaches back there where the y value is -1, and it reaches back there at 2 pi over 3. So we're our b value, so our period, we're going to have to divide 2 pi, our b value, to find it, by 2 pi over 3. So I'm going to write it out differently than what we have here just to make it easier for division. So 2 pi at the top, we're dividing it by our period, which is 2 pi over 3. So that's the same as doing 2 pi multiplied by 3 over 2 pi. The 2 pi's will cancel, leaving us with a b value of 3. So that is our horizontal stretch. So the factor would be 1/3 if you actually flipped it. Our d value is going to be our midline value, or we call this vertical displacement. So this is where you take your max plus your min divided by 2. Our max we know is at 1, plus our minimum is at -3, dividing that by 2. So that will be -2 over 2, which gives us -1. Okay, so far we have everything except for our phase shifts. So our phase shifts will be the only things that change sine versus cos. So we're going to start by writing the cos equation, or sorry, the sine equation. So this is for A. So for A, you're going to write y equals, your amplitude is 2, sine, B, we know is 3. Then we're going to have x, we're going to have some space for that c value that we're going to have to find, and then -1 for our d value. Okay, so what we need to know about the phase shift is that we have to compare it to sine. Well, sine always starts from when we're at the midline, so this is our midline right here, which is at -1. We should always find that wherever the midline from there goes upwards, that would be where our graph is supposed to start at. So this is our next midline value that it goes through, and it should always go upwards to the maximum from that point. I couldn't use this one because this one went down towards the minimum. So you should always be going up to the maximum, and this is where it actually should have started at. So the graph has moved pi over 3 units to the right. So pi over 3 units to the right means minus pi over 3. So that would be what sine should look like. And for cos, you would write y equals 2 cos 3. Everything else stays the same. X and then minus 1. So the only thing, again, that we have to change is the c value. So cos is way easier because we just have to look for the closest maximum. The maximum should always be on that, should always be where it starts off at. So it should have been there. So I always pick the closest one. So this is my closest maximum. And as you can see that it should have been here on the actual y-axis, but it's moved that many units to the left. So we need to figure out what that interval is first. So pi over 3 means 2 blocks. So if we divide that by 2, we know that each block is pi over 6. So all we need to write is that it's gone pi over 6 units to the left for cos. So I'm going to go plus pi over 6. Now what you can do to check is you can graph both of these and see if it looks like the image that we have right here. So as long as you change the window to look exactly like this, then you should be able to check the values. So make sure that you're in the right mode first of all. And then change your window so that you have -3 as your minimum. And then you have +1 as your maximum. And we can use 0 to, if you wanted to pi, going up by pi over 6 is the interval. Now if you graph it, it should look identical to what we have. You can even check some of the values to see if it corresponds, but this is how you actually want to write it out. Okay, so use technology, use your graphing calculator to check your answers. And our last example is example number 5. So it says the depth D in meters of the water in the harbor of New Westminster, British Columbia is approximated by this equation. T is the time in hours after the first high tide. Graph the function for 2 cycles starting at time equals 0. Okay, so you want to put this into your calculator. We know the amplitude. Our t value will be represented by x in this case. You're going to have to close your brackets, and then, so I would put brackets right here around these two things, and then you're going to add 3.7 outside of it. Make sure that you are in radian mode, of course. And then you are going to have to change your window. So what can help you to figure out your window is looking at like your midline. So we know that our midline is at 3.7. So that is, we want to be above the x-axis for that. And then we also want to look at the period, because for B, if we solve for the period, that can tell us if we want to see 2 cycles, how long should we have our x min and max for. Okay, so 2 pi over 13, if we look at the bottom number, 13 seconds is how long our actual period is. So 13, in this case, it's in hours, so it should be 13 hours. because we're looking at 2 pi over 13 as your b value. And in your b value, the bottom number is your period if it's in fraction form. So that's a little hint to you. So it's 13 hours. So I'm doubling that if I want to see 2 cycles. So I'm going to go up to 26. Okay, so the window that I'm using to see this, I'm going to write it down. Is for X, I went from 0 to 26 to see 2 cycles going up by 1. And for Y, I can go from 1 to 5, going up by 1 as well. And so for this, for X, I'm going to label it as T for time in hours. And your Y value, I'll label as D of T. Okay, so with this value, trace, 0, enter, you're going to want to start labeling some points. So we know that we have a y-intercept of 0 and 4.3. So we know that that occurs again at 13 seconds. So I'm going to I'm going to try to figure out what scale I should use for the bottom for my time. Okay, so I'm going to go up by 2, 4, 6, 8, 10, 12, 14. So every 2 hours is what I'm going up by for my scale. And then you want to start plotting these values. So I know that at 13, I'm going to be back at 4.3. And at 26, it's going to be back at 4.3 again. Okay, so once you have some points, start connecting them just to get that general shape. And it just repeats itself. Okay, so that's my 2 cycles starting at t equals 0. What is the period of the time? We already determined it's 13 hours. Now, question C, it says, if a boat requires a minimum of 3.5 meters of water to launch safely, for how many hours per cycle can the boat safely launch? So what I'm going to do is on my graphing calculator, I'm going to label for C, Y2 to be 3.5. And we're going to see where it cuts along our graph. So 3.5 is what I'm labeling Y2 as. So as long as the water is above 3.5, then that's how many hours per cycle we can actually safely launch. So we want to figure out the intersection between the graphs. So I'm going to kind of show you what that looks like on the graph here, and then I'll erase it. So 3.5 is about here. So what you want to do is find this x-intercept and this, and you want to find out the time that this is occurring here to go from one x-intercept to the other. So if you can find that, then that would be your answer for C. Okay, so second trace intersection, number 5. I'm finding one intersection by going as close as possible to it and pressing enter 3 times. And I get that one intersection occurs at 9.04 hours. And then again, I'm going to find out the next intersection. So that's going to be at 16.95, and all I have to do is subtract these two values. So to get my answer, I'm going to take 16.95 and subtract 9.04. Okay, so that is going to occur for 7.91 hours. So that's the distance that I care to use. So it's going to be 7.91 hours. So that's how long they'll be able to launch. And then question D, it says, what is the depth of the water at 7 hours? So at 7 hours, you can just go trace in your calculator and enter x as 7. So trace 7, enter. So I'm going trace 7, enter, and I get 3.12 hours. Actually, that should be in meters. 3.12 meters. So what is the depth of the water at 7 hours? We did that. So trace 7, enter. At what other times is the water level at this depth? So we can put, again, we can make y2 in this case, 3.12 meters, and see where that happens. So change your y2 to be 3.12, and then you just want to find any intersection that occurs. So a quick way to do that is to use the general solution. So we know that it's going to occur the first time at 7, right? So it's 7 hours. And so then you just have to add your period times n, because if I add my period times n, where n can be an integer, that will take me both in the positive direction and the negative direction, so that can be any time. Now, since we're in hours, I don't have to do integers. I'm going to use, I can't have negative values, so if I subtracted 13, it wouldn't give me a logical answer. So I'm actually going to change that slightly to be n can be natural numbers, where only positive numbers like 1, 2, 3, 0, 1, 2, 3 are actually whole numbers, because I do want to include 0. So I want to go 0, 1, 2, 3, etc. And that's what I'm placing in there. And if I keep adding 13, I'm always going to get to the next value. So that would be a quick way of doing it instead of just finding every intersection. Okay, so that's it for our lesson 5.2. Try some examples in the homework. Ask me questions if you guys have any.